Okay, boys, let's get started with. Let's get started with our lead code problems. Um, uh, here, let's choose something. I like linked lists. Choose linked list. Remove duplicates from sorted linked lists. Okay, let's try this. Remove duplicates from sorted linked list. Removing duplicates from sorted linked list. Okay, so remove duplicates from sorted linked list. Given the head, let me just. Okay, better. Given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. Okay, so here's an idea. Okay, I right. Okay, there is next. There is no none. Okay, it's a single linked list. So head optional list node. Optional list node. We have a head of the list. Now none. Okay. So we have this list, right? Say I am at the head. Can I have two pointers in the list? Right. Um, yeah, it's fairly easy. We keep moving it to the right. Right. I will. I think I have a value where it can check the value. I will just look ahead. If both of these values are the same, uh, yeah, you know what suitable will be, right? Like I can treat it as an array. Like the last question, I can have an it is sorted, right? So like we have all the ones in a line. It will be so easy to skip them. But should I change? I need to return the sorted linked list. Does uh, list node list node. Okay, so I have to return a node sorted output node. Do I have to the return the linked list sorted as well? Okay, so I have to return the reference to the head as well. Okay, so that's yeah. I can just go if they are same. I will check same, not same. I will attach this head directly to it, and I will increment. Right, I can increment. Uh, then I'll come to this. Then I will check uh, if we don't have. Okay. If next is not same, right? Then we simply move to the next one. Then we have 3, which of 3's. Check if the values are the same. If the values are same, we skip. Then we check with this. The value is not same, therefore we attach this head there. Okay, that should be easy to do. Okay, so let's I want to declare a variable for the current node, right? And let's say car equals to head, and we have a variable to look ahead. Which will be, let's say, temp dot next. Then I'll say while temp is not equal to none, right? Well, temp is not none. We'll keep looping it, looping ahead, right? Okay. Then I will check if the values cur dot val equals to temp dot val. If this is the case, then I will simply uh, move ahead. Dot next. And if it's not the case, else we increment current to current dot next, right? I feel like there should be a else if current val is not equal to temp dot value, then we increment current temp dot next, and we continue the loop. Continue to okay. I don't increment, then I don't okay, if it is not equal to, and okay, and we are if the values are not same, what do I want to do is okay, if the values are not same, if the values are equal, I increment temp to the next one. Then I again check if the values are equal. Then I'll come down to if current value, and we will check if temp dot value is not nice, right? Where we are going current dot value. If k, then we increment temp. If current value is not equal to temp dot value, then we increment this, right? If it is indeed equal, okay, let's is not equal to this, then I'll go LF dot value is not equals to current dot not equal to next. Do I but it will be easy for me to skip, right? But there are no indexes, so you cannot skip like the indexes would. I feel like I need to repeatedly recurse here uh, till this condition is satisfied. Okay, if current value is not equal to temp dot value, right? If current value is not equal to temp value, we increment current. If current value is equal to temp value, then we increment temp. Okay, say we increment temp. Um, we will set the current, the next of current to, to equals to the next of equals to temp. Set the current term, and then we increment current, right? Else we continue, and then we return head. I feel like that should work. No, it would be expected. And I got a 3 and a 3. Expected, yeah. Okay, so there is something wrong. I got to 1. Okay, it is not handling the last case. Okay. Equals to tell, and let's put a condition temp dot if temp dot next equals to none, then we simply, what do we say? It would be the last one, right? If temp dot next equals to none, then current dot next equals none. And let's put it in a else block, else if. No, I don't need an else if, I just need an else we continue, right? Current dot next should be, and this, I think this denotes the last node, and we increment it. Current dot next, I just say temp equals to none. Let me try this real quick. Resolution unindent does not match. Oh shit. Shite. I did this for the condition to loop out. Let's try and submit it. Hmm. Okay. Empty. Uh, I need to check for an empty head as well. Okay. Then let's see if head equals none, then return head. That's so. 1 millisecond. Right. This is the way we increment it up till we don't find a new one. If we do find new one, that is what I had done, right? If the values are not same, current.next equals to temp, and then I set current to right. That's what I'm doing. कि इसको next को मैं जहाँ पर भी temp है wherever temp is I connect it with it, right? And then I say that current equals to current.next equals to temp, and I increment, I can just say that current equals current dot uh, nah, this shouldn't be it. This shouldn't be like this. Okay, see, the current dot next equals to temp, right? I did not increment temp here. If head is none, we return. Then else we set variable for the current node and variable for the head node. So if values are not equal, temp I set temp to the next one. Then I say that current dot next wherever temp is, say my temp is here. This is my current. So what did I did? I do current dot next equals to temp. Okay, so I basically attach this node with it, right? Then I set current to be this, and I should increment temp as well. Current equals to temp, and temp equals to temp dot next. Then I I feel like temp equals temp next, and let's try this real quick. This should, let's try. Okay. Temp equals temp next. Current equals to temp, and temp equals temp dot next. Then we check again if current value, right? After I'm here, this is temp now, and this is current. Then I check if this value is same. If it is not same, then current dot next equals to temp, current equals to temp, and temp equals temp dot next. I increment temp. Current value is equal to Next equals to temp. Just set temp dot next is not equal to null. I feel like that would solve the problem. And the next one is not. No. Now both of the answers are wrong. Okay. Temp is not null. Temp equals temp dot next. Both the values are same. I equal loop. I don't need the continue. Denotes the last node. Current dot next equals to null. And temp equals none. That was my fault. That basically I forgot to increment the temp, so it had to check that loop again and again. Okay, I did that. So let's check the video solution once.
Hey guys, Greg here. Let's solve remove duplicates from sorted list, LeetCode number 83. So we are given the head of a sorted linked list, and we need to delete all the duplicates such that each element appears only once. And we return the linked list sorted as well. So if we are given the list of 1, 1, 2, well, the duplicates are going to be beside each other because it's in sorted order. So here we just remove this 1 here, and so we'd have 1 pointing to 2, and we'd return that head. If we had this example, 1, 1, 2, 3, 3, we would want just 1, 2, 3. All right, so suppose we were given this list. It's the same one as the original example, and we'd have a pointer head pointing to this node here. Now, as usual, we would get a pointer C, which is going to point at the first node, the head, and from here, we want to remove the duplicates. Now, if there is a duplicate, they're going to be right beside each other, and that means you're going to have one that is equal to the next one. So to even consider if there is a duplicate, we need to check if we have the current, and we also have current.next. Because if we didn't have current.next, well, there's no point of even asking this value here. There's no chance of a duplicate. So we check if we have the current and we have the current next. Okay, there might be a duplicate. If their values are the same, they actually are in this case, then we want to skip this value here. To skip over this node here, what we do is just set current next equal to current.next.next. And that is going to skip over this node. Now we've lost access to this entirely, but that's okay because we don't actually want to use this. And here we are not going to move cur over because you could have had more duplicates to deal with. Say that this was also a 1. Well, then we'd want to do the same thing. We would actually just want to skip over both of these, and so we'd skip over 2 here. So when we are doing the skipping thing, we are not going to move C over. We want to skip over all of the duplicates. Okay, so we've lost access to this node right here, but that's totally fine. We don't ever want to use that. We want to skip that over. We want to see again, okay, are both of these actually nodes here? Do we have cur and do we have cur.next? We do actually have both of those things. They are both valid nodes. Are their values equal to each other? So do they have the same value? No, they are not equal. In that case, we actually want to use this value, and we must have removed all of the duplicates of this kind. So we simply just set cur equal to cur.next, which is now pointing to this node. Now at this point, we are now looking at a different value, and we may have to
Okay.
remove duplicates of 2s. So say for example this was a 2, well then we would actually want to adjust this to skip over that node over to here. But that is not the case. This is a 3, and if they are different valued, then all we want to do is just move cur over. And so we have no duplicates. We are ready to move on to the 3s. Over here we have cur and we have cur.next. Okay, do they have the same value? They do have the same value, and so we want to skip over this. Now this is okay. We can actually skip over just to the none or null over here. So this is implicitly pointing to null. That's okay. We can still point cur to be cur.next.next. That is what points to over here, and that's totally fine because we skip over this node. And then on the next iteration, we don't have cur.next here. Okay, we have cur, but we don't have cur.next. So because of that, that is actually where this is going to complete. And notice that this is totally ideal. If we clean this up here, removing the stuff that we don't have anymore, this is exactly what we'd want here. We wanted 1, 2, 3. It has no duplicates. Let's actually just clean this up a little bit more over here. Okay, that is our list. We have cur at the end. That's totally fine because we can just return our original head. What if we were given a list with literally nothing? So head was pointing to just null here. If we pointed cur to be the head, well, that's just pointing cur to be null, and so there's nothing to do with that. Therefore, what we'd want to do is just return the head, which is returning null. That's what you'd want to do because we weren't even given a list in the first place. Okay, so let's write our code. Okay, so we'd want to set cur equal to the head, and we'd want to say while we have cur and we also have cur.next, they're both valid nodes. So do they have the same value? Is the cur.val equal to the cur.next.val? If they are, in that case, we want to skip it over. So we want to point cur.next to be cur.next.next. Okay, this itself might be none. That's fine. We're skipping over cur.next. Now, in that case, that is all we want to do in that iteration because there may be more duplicates of that kind to remove. So we're going to leave that as is. Otherwise, if their values weren't the same, but they were actually still valid nodes, well, that's the case where you just want to move cur over. So we'd set cur to be cur.next. We have no more duplicates to remove of that kind. This is actually the entire code here, and as we said, we can return the head. And that's even going to solve the weird edge cases where, for example, if you had 0 nodes, that would mean head is just null, and so you'd return null. That is also ideal. So if you were to run that, that will work. Okay, so the time complexity of this algorithm, this is going to be big O of n. We are basically just going through the linked list as we usually do, and the space complexity of this, we're not really.
Okay, so the logic was same, but the implementation was different. So just okay, we'll check while we have a valid cur and cur dot next, right? If cur dot valid is equal to cur dot next dot val, then we attach with that node cur dot next dot next, and if the values are not different, then we simply take dot next, and I won't have to check for this case, right? Same idea, different execution. 3 millisecond. um because it is. So you were saying cur equals to head. This actually is because we are checking querying two things. This is simple, but my first solution was fast. Okay, hold up. if you're saying that this was actually temp, you can say well temp. If value are not equal, then current dot next equal to temp, and current becomes temp. Value are not same, and we increment temp. Then I have a value. If values are same, if it is none, if the next is none, then denotes the last node. They come out. This temp equals to none, and then it's temp dot next. So you say that this is in fact faster and better. Yeah, same idea, but for some reason, maybe it has something to do with the checking while current and current. Uh, I don't understand why it's fast, but it is. But I think I'll prefer because it's no. I should prefer that because it's not fast, though it is easy to understand. Okay, let's try it in C++. List node. We have a list node next. List node next. Okay. This node has this list node. We have various constructors for its value. Okay, so node current equals head. Okay, we are providing a reference, soul, a pointer, and rest node temp. Okay, I'll try first with Greg's way. I'll say while cur and cur next are both are valid. If cur does it have a value? Yeah, val equals cur dot next dot next value. How it feels coming back. Alright, if both the values are same, then what we do is I will simply increment the next. And else, if both the values are not same, then I will manage it, and at the end right, okay, and then we return head. Then okay, let's try this. Right, and we get right, we get a 0, which is because this is a better way, but I don't know why in Python it was like that. So there we go. What's the time? Spent 34 minutes on this. Right. Okay. Okay, so I've done this. Reverse the linked list. Stuck. Very small game. Trees, heaps. 2 pointer. Squares of a sorted array. reverse the string. You know what should I be doing? It's time to pencil stop. Okay, let's try. Reverse the linked list. Remove duplicates from sorted. It is. Hmm. Okay. I am afraid. What if I will not be able to do that? It doesn't make sense, you know. Either you do it or you don't. It doesn't matter. Let's go. Okay. Okay. So, reverse linked list. Given the head of a singly linked list, reverse the list and return the reversed head. I have to reverse the list and return the reversed head. Okay. Example number of nodes 0 and 5000. Okay, so how can I reverse the linked list? Let's see. Let's see. We have to use list. Okay. Yeah, I have this head. I want to reverse the list. It is a singly linked list, right? It is a singly linked list. Okay. So we start here. Okay, what are some of the ways we can do this? Head. I can move head here. Okay, see, one of the ways um, is to swap the values, but then the head, but then the list won't look like that. See, what I need to do is I need this to have the next is this, right? I need to flip the list at this point such that all these values are here. How can I do that? First, let's do Python 3. Next. Head. Okay. Right. Okay. I have to constantly. Okay. I say. Let me just go 2, 3, 4, and 5. Let me assign this as the next. Okay. I'll first assign. Okay. Let's have 2. Right. I think I'm going to need 2 if you like. Uh, right. Then I swap the next. So I say that this is my that that t dot next. How could you do that? Okay. T dot next. See, I say I swap. Okay, hold up. And then reverse the list and return the reversed list. Okay, well, you know, I feel like reversing is more about reversing the values. I can keep the list as is, just swap the values, right? Also, when I sort a list linearly, okay, say I swap, I get a 2, I get a 1, but then it is not an array, and swapping is not the best thing to do because then the list would be like 2, 3, 4, 5, and 1. That's basically sorting. O of n square. You sorted the list. You did. You did like swap. I apply swap operation again and again and again. And I wouldn't even know when to stop. Right. I wouldn't even know when to stop. So how can I reverse a list? But how can I mirror the list around a point? Right. Okay. I can set its next to here. Right. But then I would have to travel to the end every time, which would be that is equivalent of 4 n square. But see, this works, right? This works. I can go to the end if I find next. I go. I'll take this and I'll set its next to be the head. Then I'll update the head to this position. But again, the question is, when do we stop? We need to linearly. When do we stop? What if the list is really long, right? Uh, Um, okay. How to I need to flip. Okay, the thing is that they don't have a previous element, they only have a next one. So, shit, dude. What the fuck? Alright. How can I Alright, dude, we'll just for the time that yeah linked list. Okay. We have the 2, 3, 4, 1, 2. Okay. 2, 3, 4, 5. I want to make it 5, 4, 3, 2, 1. What if it wait, I cannot depend on finding the middle element. Um so what do we do? What do we do? If I could swap these nodes, then it is equivalent of a bubble sort. But at least we know the size of the bubble length, but we have no information about the length of the linked list. Just have a how do we reverse this list? Think about it. Think about it. What is the you know update? I cannot do that. What I thought is store the values, right? Just go through that linearly, store the values, right? Then, just from this array, assign the values to. Oh my god, um, value empty list. It's just funny while say current that current equals head. while current again values dot append cur dot val and current, but it equals storage, and current equals to current dot next. Then we'll set current equals to head again, and while okay, I would just update the value for I in values. You could just say current dot well equals I, and current equals to current dot next, and then we simply add it on the head. But I think it will in a sense work. It didn't even work, dude. Okay. Ooh. Okay. For I in range, it is inclusive, exclusive to 0. It's 4 to -1, and we'll say hey, where I in range 4 to -1. No, for I in range 4 to -1. Nice, bro. You are um exit value equals to values reversed. I think that's how you reverse the linked list, isn't it, Brian? Or list, sorry, values. Let's try. Yeah, okay. I equals len values -1, and say I, but in case of 0, it's greater than equal to 0. I -1. Uh, I mean it is sketchy, but it works. Like, yeah, it does work, but it's not the right way to do that. Yeah, it takes up memory, and it's a of n solution, I think. Yep, of n solution. But this is not the right thing. So I'll think about it once again when I get the time. For the time being, it's just maybe 5 minutes I can think about it. Um, it's linked list. Okay. See, what I can do is can I can check if let's say if next exists, right? If the right if its next exists, right? I swap it with that. I swap positions with that. I feel like one, two, three, four. Okay, see. I feel like I can stay here. I say you can swap with them, right? If there is a next, right? Okay. Check. There is a next, right? Okay. Like no, there is not a next. Then I can just go put it here. I swap these. Um, right. Do I swap the values or do I swap the nodes? But linearly, traversing the array again and again, it's just not viable. What should I be doing then? What should I be doing then? This is swap with this. Keep it here. Right. Then I mm, register as on. Right. I like there will be a solution, but one that I cannot think of right now. So I've never thought about reversing a list. So do you reverse the list? How do you achieve this monstrosity? Okay, see. I check here. Okay, great. Uh, I won't actually move it. I'll swap it with the next one. Then I'll move it. Okay, say um, 3, 2. If next exists, it then I'm on to here. Then I'll go if next it exists. Then we swap it with this. 1, 3, 4, and then I have 2 in the end. Right. Then I'll go if it is none and come back to it. But right, see the problem is I wouldn't know when to stop. I would not know when to stop. When do I know that my head is at the right position? That is the only problem I face right now. Okay, right. There used to be an algorithm called insertion sort. Insertion, right? Insertion, where we keep one side sorted and keep inserting things here. But these are all based on array algorithms for array. But I don't have an array, so okay. Think about it later.